We're now going to begin the next phase of our CCNP Voice Bootcamp, and that is the CIPT1 section. So we're going to first begin talking about UCM architecture and redundancy and planning options. To begin with, let's just do a brief recap. And actually, even before I begin anything, remember that we're not going to go over every single thing related to UCM. Anything that we had already covered in the CCNA Voice Bootcamp, we might hit on and touch on a few of those topics and go a little bit more in depth. We will go back and do phone registration again, but we're not going to go over every single thing. So we're not going to be talking too much about users and groups other than when we actually go to apply them in our demonstration. But we won't be talking about the theory of things like that or LDAP or things like that. Those are going to be important on your CIPT1 exam. However, we've already gone over those in the CCNA Voice class, so we're assuming you've already gone and watched that particular product and taken those exams, or actually that one exam. So to begin with, let's do a rehash of the UCM database itself. Unified Communication Manager, or UCM, uses an IBM Informix database, and it stores static configuration data such as servers, their enabled services that are within the cluster, devices such as phones, gateways, trunks, and as well as users, the dial plan, etc. There is dynamic data that's utilized by something called user-facing feature, a UFF. User-facing features are things such as call forward all, message waiting indicator, or MWI, privacy status for a shared line, do not disturb status, and status for a login to a particular hunt group. So UCM database is basically a single master database model. That is that read-write database access only exists for the publisher. The subscribers all read off of the publisher database. The exception to that rule is that subscribers are allowed to read and write access to the database for specifically UFFs, or user-facing features. And then those are going to be full mesh synchronized between all database servers. The reason for this is, and by the way, this is not the way that UCM has always been. So we're specifically talking about version 8. If you go back in some previous versions, let's say we were to go back to a very widely deployed popular version of UCM, which was version 4, more specifically 4.1.3, we did not have these user-facing feature options to allow a subscriber to write to the database. So what would happen is, let's say we had a publisher and 3 subscribers, and we're going to talk about how to size and how to deploy those in this module. But let's say we had a publisher and 3 subscribers, and they were running UCM version 4. At the time, it was still called Call Manager version 4. If the publisher fell down or died, could not be reachable for whatever reason, the subscriber servers would still work to process calls. There would be no problem with call processing. But while the publisher was down, until it had been restored, rebuilt from backup, what have you, the users, if I was a user and I went to go press call forward all, wouldn't work. Absolutely wouldn't work, because the subscribers could not change that database field. If I needed to have a message waiting indicator flipped on, might flip the actual light on, but it's not going to indicate so in the database. If I go to take privacy off, that's not going to work. There's a lot of features that did not work if the publisher had died. Now we're still going to talk about, on the next slide, services that rely on the publisher. So there are still things that the publisher must be alive in order to accomplish. First off is just adding or provisioning just about anything. But we're going to talk about some other specific things. But the important bit here is that if the publisher dies in UCM 8, then we still have the ability for user-facing features to work. So whatever subscriber my particular phone happens to be registered to, I will be able to, let's say, issue a call forward all. Maybe I say call forward all to voicemail because I'm going to lunch. And then what's going to happen is that particular subscriber that my phone is registered to will write that call forward all to its database in reference to my phone device name, my SEP MAC address device name. And then it will go ahead and full mesh synchronize that between all other subscribers. And then when the publisher comes back online, push that change up to the publisher as well. So taking a look at services that rely only on the publisher, anything related to CCM admin, that is the CCM admin user interface that we took a look at in CCNA Voice. This is related to everything that is being provisioned. Anything related to the CCM user web interface. Okay, so any provisioned user settings from the web interface. Now I could do call forward all from my phone. I wouldn't necessarily be able to do that from the CCM user page. Bulk administration tool, cannot do anything there. AXL, so XML, but the administrative XML interface as defined by Cisco's schema for such. AXL has the ability to provision just about anything, change and look at. I could still look at anything using AXL if I was pointed to another subscriber server, not a publisher server. But in terms of actually changing the database through AXL, I won't be able to do so. Axis-SOAP is actually a way of enabling and disabling services. That will be not able to occur if the publisher is down. The CCM process itself for inserting phones. Now, the CCM process itself in relation to call processing nodes or call processing engines on other subscriber servers, that will continue to work. I just can't insert a phone. LDAP. I can't synchronize the LDAP. Now, updating the end user table. Okay, if the LDAP has already performed a full synchronization and I have that end user table already provisioned, or already populated, I'll still be able to see those from the subscriber, the user table. It's just that any changes that was made on the LDAP itself, let's say Microsoft Active Directory being the most common, those of course would not be updated until the publisher came back online and either was forced to do a manual LDAP sync or waited till its regular update interval. And any updates to the license table. So looking at all the user-facing features, we already mentioned call forward all, MWI, we already mentioned privacy, DND. One other thing is extension mobility. Okay, so I have the ability to log in and log out of extension mobility even when the publisher's down. Hunt group logout we mentioned, device mobility. And we're going to talk about extension mobility and device mobility. Those actually come about in CIPT2. But as far as in terms of mobility in CIPT1, we'll be talking about and doing demonstration with unified mobility, which continues to work if the publisher is down. So does extension and device mobility. Hunt group logout, status for end users and application users of their CTI CAPF. CTI is computer telephony integration. CAPF is the certificate authority proxy function. And again, these don't rely on the publisher because they can be written to individual subscribers. Speaking about the database, we want to talk about database access control. So database access between members of a cluster is actually protected by Linux IP tables. Remember, we're running on Red Hat Enterprise Linux is the base of, and of course it's a whittled down, kernel that has been highly customized by Cisco to essentially make it an appliance, but it is running IP tables and we have a dynamic firewall. We also have a cluster-wide security password. So there's really a two-phase control of access over the database. And there's a special configuration procedure that's required to enable database access for the subscribers. First of all, on the publisher server, you're supposed to add a list of each subscriber server before you go to do the installation of the subscriber. We don't actually cover the installation in this course, mainly because it takes an enormously long time to just sit there and wait for the disks to spin up. It's more or less, it really is just a pretty standard, if you've ever done any sort of a Linux distribution installation, especially a Red Hat one, the screens haven't changed since I first played with Linux in like 96, something like that. I actually think I played with, it might have been 95, 96, not too long after Linus Torvalds came out with it. But at any rate, the distribution for Red Hat really hasn't changed in its initial wizard that it came out. And so there's just some basic ASCII-looking screens, and they ask you a few questions, of course, such as IP address, subnet mask, default gateway. They also ask you for the username and password for the administrative access for the particular server you're creating, for the whole cluster, and they also ask you for a cluster-wide security password. Oh, well, as well as a few other features like NTP. One thing to note is that you do have to have an NTP server available. And in version 8, this was not so in version 7, in version 8, the NTP server that you're referencing when you do your installation must be of stratum 4 or lower. Lower is a better stratum. So all you have to do is turn on a Cisco IOS router, configure your time and date, do from exec mode a clock set, then go into config T, say NTP master, and just say NTP master 1. You're declaring yourself a stratum 1 clock. It's of course not true, but it will certainly suffice. And then point your installation to that NTP server when asked about NTP. Obviously, make sure it's on the same network or at minimum reachable. What I'll do is I'll probably include, I'll try to include at least a series of screenshots of the installation of a given server, UCM Publisher, for instance. At any rate, during the subscriber installation, you're going to enter the same database security password that you configured as the cluster-wide security database password for the publisher server. And of course, you're going to use the same host name and or IP address that you used when you created the instance of the subscriber server in the CCM admin user interface. And I'll show you where that is as soon as we get to our demonstration. Next, we want to take a look at licensing Unified Communication Manager. Two basic licensing models are available. We either have device-based licensing or user-based licensing. So device-based licensing uses something called DLUs, or Device License Units. And I misspelled that and it says unites there. I'll be sure to change that before I post the slides. And so these DLUs are used by the individual devices. And different device types, as we'll take a look at here in a moment, use different number of DLUs. So I might have, it typically depends on the capabilities of the phone. So if I have a phone that has 2 buttons and does not support video, it's going to use less DLU than a phone that has 6 buttons and supports video. And if I have a phone, let's just say I have a phone that has 6 buttons but does not support video, it's going to use less. So for instance, maybe a 7960, it's going to use less DLUs than a 9971 who has, let's see, it has 6 lines and it supports video natively. Okay. The other type, user-based license, is based on something called CUWL, or Cisco Unified Workspace Licensing. And this licensing is per user and it's really independent of the used devices. So it really is independent of how and where a user uses Cisco Unified Communications. So taking a look at the types of licenses, we have three different types. One is a software license required just to use the UCM software to begin with. The next are DLUs required for the devices, phones or soft phones or whatever. And as I mentioned, they're dependent on the phone capabilities. Next are node licenses, and these are required. So the software license is just to run the CCM software, or the UCM software itself, period, just to install Unified Communication Manager. Then we have the concept that not all Unified Communication Managers, as we're going to take a look at in a visual perspective here in a moment, not all Unified Communication Manager servers are going to be used for call processing. Some will be used just as, let's say, the database publisher. Some will be used for things such as music on hold or TFTP or just CTI. And so node licenses are going to be required for each call processing server within the cluster. So only if it's actually running the CCM service. Okay? Licenses are going to be required per cluster and provided by license files, text files that are .lic. And those are going to be bound to the MAC address of the publisher who is running the actual licensing service. Now, the UCM server or cluster will continue to work if the licensing service is stopped. However, no configuration changes or charges, as I put, changes will be allowed. Okay, so if for some reason the licensing, first of all, if the publisher goes down, we can't really make any changes anyhow. However, if the licensing service, for whatever reason, fails or we stop it, then I won't be able to add, even if the publisher's still alive, I won't be able to add any actual devices. And the licensing service only runs on the publisher. This doesn't affect user-facing features. Obviously, because if it did, the publisher going down would inherently stop the licensing service and no UFFs would be allowed to occur, but they can. So in the license file, it contains the following information: the MAC address of the license server, the publisher, and we're going to talk about how that will vary if we happen to be running virtual, basically UCM on a virtual machine in VMware, ESXi. It will also include the version, the major release of the UCM software, the number of node licenses, the call processing engines, and the number of DLUs. And license files are cumulative. So if I start out with, 200 DLUs, which is a very low number, actually 150 come by default. So if I start out with 1,000 DLUs, which does not necessarily mean 1,000 phones, and we'll take a look at how many DLUs are required for each particular device in what's called the license unit report when we look at our demonstration. But if I start out with 1,000 DLUs and later I need to add on another 1,500, I simply buy another license file for 1,500 and I now have cumulatively 2,500. In order to obtain my license files, the Cisco Flex licensing license manager process is used or utilized. And we're going to take a look at that next. And the various file integrity of the license file is ensured by a digital signature. Of course, this is using an algorithm that is certainly created, just like every product key or serial number, to, as best it can, not allow it to be hacked, and so therefore ensure that whatever license file you have is valid. And so in other words, you couldn't just open a license file and even though it's just a text file, and you can see how many DLUs or whatever it is you're buying for, how many call processing nodes that license file contains in it, you couldn't just simply change the number and then upload the file. That digital signature is basically a one-way hashing algorithm that the UCM knows how to interpret to make sure that that file has not been tampered with, is a valid file. So looking at the FlexLM license process, The way this works is that the customer places a PO with the various partner or distributor for the actual UCM product. Then the manufacturer scans what's called a product authorization key or a PAC code, and it records it along with the purchase order. Next, you get a physical product with a paper, and that's going to contain that PAC code that's going to be delivered to the customer. The customer is going to take that PAC code, presumably you, or maybe your consultant, you would do this on behalf of your customer. Take that PAC code and you're going to enter it at a specific web address, which is stated on the paper, basically at cisco.com, along with the publisher MAC address. And there's actually a virtual license MAC address that's used if you're using VMware ESXi. The easy way to do this, to find out what that virtual MAC address is for licensing purposes, is simply to SSH into your publisher and issue the command show myself. Show myself will tell you some various things like host name. It will also tell you the virtual license MAC address. And we'll take a look at that a little bit later as well. Then the Cisco license fulfillment infrastructure, the backend server, validates the PAC code, and it uses its license key generator to create a license file, and you're presented with a download so that you can download that file. Or it may be emailed, just depending on the actual PAC code that you're entering. And typically the file has been historically emailed. They've talked about adding on just an immediate download. At any rate, the customer installs the license file on the licensing server, which will always be the publisher. Now, this is not just for UCM. This is also for some other unified communications servers. For instance, the CUP server also has a publisher, and it runs a license service, and the license file has to be installed there. Unity Connection is a little different, but it also has a license file. And then, as I mentioned, additional licenses can be ordered and added cumulatively in aggregate to the publisher. So, looking at the various components of licensing in UCM, we see that we have the license server, keeps track of the licenses that are purchased, as well as how many DLUs have been used from that. Or if we're using the workspace licensing, what user workspace licenses have been issued. The license manager is the service on the UCM that acts as a broker between the various UCM applications that need to use licensing and the actual license server itself. There's the administrative subsystem, which keeps all the information about the license units handy in the database to know what each phone type will take. And it also provides us with something that we'll take a look at in a minute, which is the licensed unit calculator. It also displays to us the total license capacity as well as our currently used license count. Then there is finally something that we'll be taking a look at a lot more in T-Voice for troubleshooting voice, which is the alarm subsystem. This indicates if we've gone into overdraft. Now, in order to not cripple large enterprises who are doing a lot of moves, adds, and changes on any given day, week, or month, what Cisco allows is actually a 5% overdraft. So if I have 10,000 DLUs, I'm actually going to be given 10,500. I'm going to be given a 5% overdraft. I'm not really given those additional units, but what it's going to happen is it's not going to stop me from provisioning additional devices until I get above 105%. 100 is obviously the maximum DLUs that I've purchased, but I have that 5% overage. Now, it will still alarm and tell me that I'm in overdraft, and so it will generate alarms, and I'll know, okay, I have very limited amount or ability to add additional devices. And of course, how many devices I can add will be dependent on how many DLUs I had in the first place. That 5% is a relative number to how many your base is. But it will still allow me to add a few, all the while producing alarms. I'll know to go purchase a new license or pack code, enter that pack code, have the new license file emailed or downloaded, and then install that license file and clear the alarms for overdraft and allow me to continue to add devices. The alarm subsystem will also alarm and indicate if there is a license server issue, if it's down. Tell me if there's insufficient licenses, including the overdraft, to even add additional, and to tell me if there's a license file version mismatch. So maybe I purchased licenses for version 8.0, and now I'm upgrading to 9.0. Okay, so it will tell me if that's an issue, and Cisco will certainly provide a way to migrate those licenses when you move to a new version. So now we want to move into a topic and discuss deployment models. There's really 5 primary deployment models. We start with a simple single site. Okay, so we've got a cluster of servers. How many servers in that cluster don't necessarily matter for the deployment model, but we only have a single site. Single cluster, single site. Next, we have the deployment model of multi-site, but over the WAN with centralized call processing. So as I see here, I have branch 1, 2, and 3. They're all running some form of survivable remote site telephony, or SRST, and that could be traditional SRST or CME as SRST. Doesn't really matter. Their phones are not primarily registered to those SRST or CME routers. They are primarily registered to the centralized call processing cluster. So regardless of where the actual voice goes, whether the voice goes over the WAN or whether the voice goes over the PSTN, there's actually a design option for voice over PSTN. The signaling will be going across the WAN and terminated by, answered by, served by that central cluster. Then we have multi-site over the WAN with distributed call processing. So you see now, on the left over here, I've got my CUCM CL1, or I'm calling that Cluster 1. So Cisco Unified Communication Manager Cluster 1, and I also have Cluster 2. So I've got still multiple sites. I could even just have 2 clusters. Maybe I don't even have the branch offices. That would still mean that I have multi-site over WAN with distributed call processing. And maybe one of these sites is linked back to one cluster, maybe one is linked back to the other cluster, maybe both of these branch sites are linked only to one cluster. The point is that I have another cluster somewhere else. Next, I have something called clustering over the WAN. In this sense, or in this deployment model, notice that this is still cluster 1, but I've changed this over here to cluster 1 as well. So I have some of my call processing servers running, and probably my publisher at my main, either data center or main corporate headquarters site. But I'm actually doing inter-cluster call signaling to other servers, subscriber database servers, that are part of the same cluster, but over the WAN. Now, if you were asked in an exam about 4 deployment models, these are the 4. If you happen to be asked about 5 deployment models, the 5th would be virtualized deployment. So it just depends on how they're wording the question. Traditionally, there have been 4 primary deployment models: single site, multi-site with centralized call processing, multi-site with distributed call processing, and COW, or clustering over the WAN. But sometimes Cisco considers a virtualized deployment, so running UCM on VMware, even though that really doesn't affect single site, multi-site, centralized, or distributed call processing in any way. So why it's a deployment model, I don't necessarily know why they would consider it a deployment model, but at any rate, if they ask you about 5 deployment models and what are those, than virtualized would be. If the question includes the answer of like virtualized deployment, but it asks something related to choose the 4 deployment models, well, then you know that it's the first 4. Now, clustering over the WAN does have some restrictions. Clustering over the WAN, we have to make sure that our round trip latency is 80 milliseconds or less. We're actually going to talk about it a little more, so I just want to point out that we have to have a certain amount of bandwidth, and we also have to have, I believe we're going to talk a lot more about it in CIPT2 when we actually discuss multi-site scenarios. So here in CIPT1, what we're going to be focusing on is how to provision and set up all of the configuration, all of the intricacies with a single site. Now, I know in C-Voice we just got done talking about multiple sites, but that was in relation to CME, or Communication Manager Express. So now that we're in CIPT1, we're going to focus for this module just on the single corporate headquarters site. So it's going to have the single cluster, and it's going to have a single router 1 that we're sending all voice calls out of. When we move into CIPT2, that's where we'll begin discussing multi-site deployment. Really, we'll discuss multi-site with centralized, and more importantly, multi-site with distributed call processing, so multiple UCM clusters. And we have another UCM cluster in our voice racks that are available for rent or demonstration here that we'll be using in order to illustrate and demonstrate and really allow you to also test a lot of these features. When we talk about CIPT2 and distributed call processing, we get into some really cool things, such as the ability for 2 different clusters to dynamically exchange their DNs, their directory numbers, back and forth. And even SRST and CME can join in on that action as well. And all of the directory numbers between clusters can be automatically, dynamically routed through actually the dynamic routing protocol of EIGRP. So it's not just for IP anymore, it's now for DNs as well. It's really exciting stuff. At any rate, CIPT1, we're focusing on the single site. So with single site, everything's at one site. Simple enough. If a WAN is used in a single site model, the WAN is only used for traditional data, not voice data. If we do have multiple sites, but we're running a single site deployment, then the PSTN is used for voice calls. And so we only have to deal with a single codec, G711, or better yet, if our phones support it, G722. We have no need for transcoding. Transcoding is going between 2 different codecs, or translating between 2 different codecs. So DSPs would only be used if we have any need for MTP, media termination point, which we likely, in a single site, likely would not. But if we had any need for that, and or certainly we would have a need almost always for voice or possibly even video conferencing. In a multi-site deployment, but with centralized call processing, we use a single UCM cluster. All servers are at that corporate headquarters site, therefore a centralized dial plan. The WAN does carry voice, video, and data between remote branch offices. Call admission control and quality of service are very much both necessary. SRST, or Survivable Remote Site Telephony, with optional HSRP at remote sites is used for WAN failure. Let me just go back to my illustration of a multi-site with centralized call processing. If reliability, resiliency is of utmost importance to you or your client, and they're willing to pay the cost for that, then we can have certainly multiple, probably 2 routers here, or voice gateways that are both running the same configuration and there really isn't rsync or anything built in, so you would need to keep those configurations in sync. In fact, a great way to do that would be with EEM scripts, or a TCL script actually would probably work a little better. At either rate, you can read up on EEM, Embedded Event Manager, or so anytime a change is made, you telnet that change to the other side, allow the router to do it automatically, or write a TCL, a tool command language script that sits there and watches the config, and anytime there's a change to the primary router, writes that same change to the secondary router, or simply keeps them in sync. But I would use HSRP, Hot Standby Routing Protocol, which is a Cisco proprietary. The industry standard is VRRP, but of course, as with any Cisco proprietary, as long as you're not opposed to using a proprietary type protocol, then it has a lot of enhancements that Cisco is able to provide without having to wait for the industry to ratify it in an RFC. At any rate, I have HSRP that can be synchronized or used with CME, and all my phones simply see a single virtual IP address with which to contact and fail over, and HSRP keeps the routers straight as to who is the active and who is the standby router. And of course, as long as the active is alive, it is either in the active state, I should say the primary router's alive, it's in the active state, or about to preempt and take back over the active state. So we do have the ability to run HSRP for high availability. Automated alternate routing is preferred if call admission control says that the WAN bandwidth has been depleted. We will typically use G711 or G722 within a site and G.729 codec between sites. We could use other low bitrate codecs like ILBC or ISAC, depending on if phones support them. But all of our phones are going to support G711 and G729 at a minimum. And then DSPs or PVDMs are going to be used for POTS termination, so terminating actual voice calls. And when I was talking about a single site, I wasn't necessarily considering MTP as a termination for voice calls out to the PSTN, but in fact, that is a media termination point of sorts. So DSPs would certainly be used for PSTN voice termination. But those would be used in a multi-site centralized, as well as the need for conferencing and possibly the need for transcoding. We're going to talk a lot more about transcoding as one of the last things in the CIPT when we talk about media resources. But just as a brief introduction to transcoding, the idea of transcoding is that we need to have transcoding if and when one of two parties that are trying to establish a voice call don't speak the required codec. So think of it as if I travel, it doesn't really matter if I travel to another country or two people from two different countries meet in a middle country. If, let's say, me and this other person both speak English, however, for whatever reason, it's required that we speak Spanish or Indian or Arabic or whatever language you want to put in there. And I only speak English, which I don't, but if I only spoke English, then, and the other language required is, let's say, Spanish, then the problem is going to be, I don't speak Spanish. The other person speaks both English and Spanish, but Spanish has been required. So the person who doesn't speak the language that's required is going to be the person who needs the translation. To put that into voice terms, or to bring it back to voice terms, if I have phone A and phone B, they both speak G711, but phone A does not speak, and this typically actually doesn't happen too much with phones. It could if let's say I have G711, and instead of G729, I have G711 and a ILBC codec. And G711, both phone A and phone B speak it. However, the required codec is ILBC, and phone A does not speak ILBC, phone B does, then phone A is going to need to invoke a transcoder in order to allow that required codec to be utilized. So phone A would speak G711 over to the transcoder or translator, and then the translator or transcoder would change that G711, extract the audio and put it into an ILBC packet and send it on to phone B. So that's the idea of transcoding, and a brief, quick introduction as to who would be needing and who would be therefore invoking the transcoding services. Next, I have multi-site with decentralized. I do have multi-site with distributed call processing. First, I want to go over just multi-site design guidelines in general. So I do have certain maximums. There is a maximum of 2,000 locations per UCM cluster. Now, I know that sounds like a lot for a single cluster, but just in case you're asked about or ever need to design that large, that is the maximum sites for a single cluster. There's also a maximum of 2,100 H323 devices, whether they be gateways, multi-point control units, trunks, or clients. I have a maximum of 1,100 MGCP gateways per cluster. And I do have to minimize the delay between UCM and remote locations to reduce voice cut-through delays. This isn't just with clustering over the WAN, this is just with multi-site in general. So we've already talked about some of those needs within C-Voice of the G.114 specification for recommended one-way delay. We said it was 150 milliseconds. 150 up to 400 is acceptable, but only if both sides know about it and agree on it. The best idea with multi-site is to use something that we'll be looking at in CIPT2, which is RSVP-based locations in UCM to provide call admission control in and out of those remote branch offices. We definitely have the need to run unified SRST or survivable remote site telephony on branch routers. And so this is going to limit the number of remote offices to a maximum of 1,200 Cisco IP phones per office if we're using the biggest router that we can to support SRST. Okay, so SRST doesn't run on the 7206 or ASR series routers. So currently the Cisco 3945, which is an ISR Generation 2 router, will support 1,200 IP phones. Now this is running, and we're going to talk more about this in CIPT2, but we're going to talk about the difference between SRST, or at least traditional SRST, and something called CME as SRST. Now both traditional SRST and running CME as SRST both use the same engine. The difference is the capabilities. With traditional SRST, everything, all the configuration, which is minimal compared to its companion, all the configuration is done under a single router main configuration area called call manager fallback, call-manager-fallback. To contrast that, CME as SRST is basically the same CME configuration that we've already taken a look at, supports all the features of CME, but just runs in a slightly different mode, being SRST mode. But all the other features are supported. And so because additional things are supported, like hunt groups and things of that nature, then we have less phones that are supported in CME as SRST mode. But here when we say a 3945 router can hold 1,200 IP phones, that's using, and that's assuming traditional SRST. And if you did need more phones than that at a particular site, first of all, Cisco recommends adding another UCM cluster. Okay, my second sub bullet point there. That's what Cisco recommends. You could also, depending on how you design things, and you'd have to be careful about it, you could add another 3945 or whatever router you need to get to the number of maximum phones you need supported. And then you could actually use voice over IP routing between those two, but just local on that LAN of the remote site. And it's also important that each router would need its own PSTN circuit. Well, you could have a PSTN circuit coming in a single router. However, you would, and then you just route those calls over voice over IP over a SIP trunk or H323 trunk between the two. But it would certainly make it that your possibility of failure was a little bit higher. And if you have that many phones at a remote office, you're probably going to run another cluster. If you don't want to run another cluster, you do want to have two 3945s to split that load. You would have to split your phones into what are called two different SRST reference groups, something we'll be taking a look at in CIPT2. But you would also probably have four 3945s, two for each, and they would be running HSRP, Hot Standby Routing Protocol. Because if you have 2,400 phones at a site, or even slightly less than that, you probably have enough money in your budget to take care of what's very necessary, which is availability, reliability. So taking a look at multi-site with distributed call processing, here we have a UCM cluster at each site. Or technically you could consider CME or even another IP-PBX to still be a form of multi-site with distributed call processing over IP, but traditionally Cisco is looking at this as two or more sites with separate UCM clusters. Again, a number of the same things occur as with a multiple site with centralized call processing, such as the WAN carrying voice, video, and data. Quality of service and call admission control are very necessary. Now, with this, you have no SRST. Now, the idea is not that any branch offices that don't have the cluster there don't need SRST. The idea is that every single multi-site, every single other site has its own cluster. When every single remote site that you have in your overall organization has its own UCM cluster, that's where we don't need SRST, and it scales, well, I guess not quite infinitely, up to 2,000 sites. And there is transparent WAN failure because whatever we were used to when the WAN was up in terms of services, in terms of how our phones were registered to UCM, their behaviors, all of that stays the same if the WAN goes down because we still have our local cluster. They may use H323 gatekeeper call routing and call admission control. Now, that might be what Cisco is still going to expect you to know with multi-site distributed call processing. It just depends on if they've updated their questions enough from the old versions of CIPT1 to support the newest features of version 8. I know that we're on version 8 of the exam, but that still doesn't necessarily mean that some of the questions in the bank of questions aren't still older questions. So why do I say that? Well, because we certainly may use an H323 gatekeeper to centralize the call routing between clusters, especially if I had maybe 30 or 40 clusters. Even if I had really 5, I would want to use it. However, when we get to CIPT2, we're going to talk about something called CCD, or Call Control Discovery, which is what I alluded to earlier, that dynamic routing of DNs between clusters using the EIGRP routing protocol. That dynamically nails up either H323 or, much more preferably, SIP trunks between the clusters. So those SIP trunks don't exist nailed up all the time. They're dynamically negotiated as a call needs to basically initiate one. So that's another method. Okay, and our call admission control there in that CCD is done with something called RSVP, and it's used in SIP preconditions. Okay, we do have automated alternate routing if we're using call control discovery. And again, we will use G711 within a site or G722, and most probably G729 or maybe another ILBC or ISAC protocol. Again, DSPs are used for POTS-based termination, conferencing, and optional transcoding. So with clustering over the WAN, we have a single UCM cluster, but servers are spread across multiple sites. Now, servers must be strictly less than or equal to, at a maximum, 80 milliseconds round trip, not one way, round trip apart from each other. And you must have a T1's worth of bandwidth for each subscriber server that's over the WAN. So if I have my primary data center and it has 5 UCM servers, and then I have 2 UCM servers across the WAN, they have a 43 millisecond round trip latency. Ping would be okay for this. Then I need to have at minimum 3 megabits, not just a 3 megabit WAN connection. That's not enough. I need to have 3 megabits dedicated just to each server for database replication. Then I also need to have a minimum of a T1's additional bandwidth for, I believe it's 10,000 calls. Okay. And as I have additional busy hour call limits, BHCAs, then I'm going to need additional T1's worth of bandwidths. So if I have, let's say, 2 servers across the WAN, I'm going to need a minimum of 4.5 megabit dedicated just to those 2 servers and calls to go through. Any bandwidth that I have, I'm really going to need to set that bandwidth aside, or at least give it quality of service, not necessarily priority. For the calls, the RTP, of course, they'll get priority, but I'm going to need to have at least guaranteed bandwidth for that 3 megabit of ICCS, inter-cluster control signaling. So the WAN now carries voice, video, data, and ICCS. As I just mentioned, call admission control and QoS, and you should remember ICCS, are very necessary. You use SRST sites that don't have a call processing engine, or CPN, call processing node, if you want to call it that. And I use automated alternate routing if call admission control says the WAN is depleted. Again, 711 within, 729 codec between sites. Again, DSPs are used for all the same: POTS voice trunk termination, conferencing, transcoding. And in all deployment types that I've listed so far, I do have the ability for PSTN gateways to also use HSRP for high availability. So I mentioned using HSRP for SRST high availability, but I can use HSRP for PSTN gateway high availability. And in large deployments, that is very much recommended. So now moving on and taking a look at 2 primary UCME, or Cisco Unified Communication Manager Express deployment models. I have very simply single site and multi-site over the WAN with distributed call processing. So taking a look at UCM deployment and redundancy. So here in this slide, we can see illustrated that we have our publisher database server, and all other servers are subscriber database servers. So the actual database is being pushed down from the publisher and synchronized to the subscribers. Of course, the subscriber servers are able to exchange with each other and synchronize with each other user-facing features, or UFFs, as it relates to the database. So we can see the different types of servers that we have here. We have TFTP servers in a very large cluster, and there can be a maximum of 20 nodes in any given cluster. But in a very large cluster, I am going to certainly make sure that my publisher database doesn't do much other than publish the database. So any changes that occur on the database. And by the way, even if I have the web server, the CCM admin web server pointed to any one of my other subscriber servers, not that I traditionally would, I would probably have it pointed to https:// IP address of the publisher. But if I did have it pointed to one of the subscriber servers, you should note that they don't make the change on their database and then push that up. It's simply that the web page on that particular server, so the subscriber servers have an Apache web server there, but they take and write all the information directly back to the publisher database. Okay? But at any rate, in a large environment, my publisher server is going to be dealing with moves, adds, and changes. It's going to be updating the database and pushing out synchronization copies of that everywhere. It's going to be dealing with LDAP synchronization. It's also going to be dealing with, I should note, if we have mobile voice access, not unified mobility, not mobile connect, which is single number reach, but something that we'll talk about at the end or near the end, right before media in this CIPT1, something called mobile voice access, then that only runs on the publisher, as well as something we'll talk about nearing the end, which is presence. Not the unified presence server, the CUP server, which we talk about in C apps, but the actual native, and really the heart of all, presence is issued by the publisher. So it's got enough to do on its own. We typically, in a very large environment or deployment, we would not have any of our call processing nodes also doing the work of things like TFTP serving or music on hold or CTI. And so in a very large deployment, and a single large deployment can hold up to 30,000 IP phones. Now, actually, that number changed in 8.6. In UCM 8.6, we are able to hold up to, and this is a theoretical maximum. Obviously, you would probably never have this many phones in a given cluster. And it really more depends on lines and other features, numbers of DNs that the phones are using. But in 8.6, that theoretical maximum went up to 40,000 phones per cluster. However, the exam is, at least so far, still based on 8.0 or 8.5, I guess, if you want, either one. But if the exam at some point changes, and they would, of course, make this announcement to be testing 8.6 or even 9.0, that theoretical maximum of phones is 40,000 per cluster. As far as we're concerned, it's 30,000 per cluster. But in a large cluster environment, I would have redundancy for everything. Now, the only thing I cannot have redundancy for is the publisher server. Cisco has been working on for a long time something called a master-master, dual active master, or at least hot standby master-to-master database model, but they haven't quite got that, all the quirks rolled out, ironed out, and therefore it's not rolled out for production. So the only thing that's not redundant in any way currently is the publisher. But I can have redundant TFTP servers, and I would. Redundant MOH servers, and I would. Now, maybe those TFTP and MOH would be running on the same boxes. That's possible. It just depends on how my baseline for those servers are. What the CPU and RAM are baselined at. Okay, if TFTP is going to be pretty active, handing out configuration files a lot of the time, but music on hold, if I had those configured for multicast, where each one is only serving an individual or a couple individual streams, they're probably not doing too much, and they could be co-located with either TFTP or CTI servers. CTI, or computer telephony integration, The CTI servers are going to be those which interface the JTAPI protocol. JTAPI is Java Telephony Application Programming Interface. They're going to be what are interfacing with any other application servers, such as CUPS, such as Unified Contact Center Express or Unified Contact Center Enterprise, such as third-party application servers. Okay, so CTI, those are going to actually be very busy answering requests. So looking at a few different models of redundancy, with what's called 1-to-1 ratio redundancy for 30,000 phones, notice that I have 8 call processing engines, or CPNs, call processing nodes. And while I can have a maximum of 20 servers, 20 total servers, including the publisher and subscribers in a cluster, I can only have a maximum of 8 call processing nodes. So here, what you see is that I have, out of my 30,000 phones, I've got 4 what are called UCM groups. And so these 3 phones represent 7,500 phones. UCM Group 2 represents another 7,500. Group 3 represents a third 7,500. And Group 4 represents a fourth 7,500 for a total of 30,000 phones. Again, theoretically. In a 1-to-1 redundancy model, what we do is essentially we've got our primary call processing node that these 7,500 phones are registered to, and then this group has a single backup. Now, it's actually possible for any UCM group to have 3 UCM servers, a primary, a secondary, a tertiary, and then actually a fourth, which is the SRST reference, in case it's across a WAN. Okay, but in this particular case, I've got a primary and a secondary. And then for group number 2, I've got a primary and I've got a secondary. But notice the primary for group 2 is my call processing node 3, and its backup is call processing node 4. So we're not using any of the servers in a dual role. Okay, so there I have 5 and 6 being used and 7 and 8 being used. So with 8 servers, I'm serving a primary and a backup, and maybe I have an SRST reference. But again, a maximum of 8 call processing engines or call processing nodes in a cluster. Now with a 2-to-1 redundancy, I have, let's say, again, 30,000 phones cut up into 4 groups, each with 7,500 phones. And instead of 8 servers, I've now whittled it down to 6 servers just to save some money. And so how I'm going to do this is I've got my primary link to CPE1 and my backup to CPE2. UCM Group 2 uses its primary to CPE3, but its backup is also to CPE2. So likewise, Group 3 and 4 both share the backup server of CPE5. Now here's another way of looking at redundancy, and in this particular model, I have 8 separate groups and 8 call processing nodes or call processing engines. And in this way, I have divided the load up a little bit more uniformly. So between my call processing nodes. So what I have is I have 3,750 phones per group. So now I can have twice as many groups. Okay, and so I have my primary group points to CPE1 as its primary, CPE2 as its secondary, CPE3 as its tertiary. Group 2 points to CPE2 as its primary, CPE3 as its secondary, and CPE4 as its tertiary. Group 3 then points to CPE3 as its primary, CPE4 as its secondary, and CPE5 as its tertiary. And so you can begin to see here so far that every individual call processing node server only is used as a primary server for one group of phones. Now, if any one group of phones were to fail, the potential for any call processing node subscriber UCM server would be to take on an additional load, and possibly 3. So if two different groups happen to go down, let's say CPE 3, and group 2, its CPE 2 goes down, all of a sudden those phones are going to come over to CPE 3, and CPE 1 server goes down, and CPE 2 server was already down. Now I have 7,500 plus 3,750. So I've got, can't do the math that quickly in my head, but I've got a little over 10,000 phones on one call processing node, about 12,000. So as you can see, and this continues to go on out. Okay, so every single call processing node only has one primary, and it serves as one group backup and one group tertiary. So it has a maximum of 3 times 3,750 phones. Now, what about when we get to group 7, who's its tertiary? Its tertiary is CPE 1. Group 8, primary is CPE 8, secondary is CPE 1, and tertiary is CPE 2. Every group still has a single primary, a single secondary, and a single tertiary. Again, a maximum of 8 call processing engines in a cluster.